Hey guys, welcome to my channel Harshu Education, and today we are going to talk about protocol oriented network layer with MVVM architectural pattern. In this video we'll be mostly focusing on network layer because let's say for most of the mobile application you need to have a network layer, right? So base of your mobile application will have network layer and a database layer. In today's video we'll be talking about network layer mostly, and how do we write network layer with protocol oriented approach and with MVVM model view model software architecture. In this video, we'll be creating an app like this. So it's a very simple application. What it does is it just hits an API call. It makes an API call and gives which gives a couple of images of dogs, and then we just show those images in a table view like this, right? So what we'll be talking about in this video is we'll be mostly talking about network layer, uh, like this is my network layer, and then how we can make it more testable uh, with this approach, with protocol oriented approach, and we'll be creating our application with MVVM software architecture pattern. So when we say network layer, what we mean is uh, it's an API call, right? So we will be making a request, and then there'll be an API call, and then we'll get a response. So what we need over here is API handler, which will have request handler, and then we'll have a response handler. So this part will be handled with request handler, which we are passing to our API. Request will be passing to API, and then we'll get a response. So response will be handled by response handler. So basically request handler will make a request like what kind of request it will have, what kind of parameters we can pass to it, what kind of headers we can pass to our API call. And then response handler will take care of parsing of our response, like whatever type of response we get, we can parse it to some generic format. So this is like the base of our application, API handler, and we have API loader as well. Loader will do the main work. We will be using URL session to make our API calls, right? So let's jump right into it. So let me just give you a brief. We won't be talking much about the UI because I want to talk more about the clean architecture and how we create a network layer. Uh, so uh, so if you see the project hierarchy, so we have created different groups. So we have UI components, and UI components, I have created custom cells. So any other UI components I'll have like pop-ups or anything else, I'll create it in UI component itself. I'll just create one more group like pop-up, and then inside that group I'll create my Swift classes. So over here in this these are my custom cells. So I have created gallery custom cell, and then I've created a different group for services. So all my services will go in this group. So for this application I just needed one service, that was gallery API. So I have created this. So this gallery API just make a request and give pass the response. So we'll be talking more about these in detail. And then I have created one more group for resources. So resources will be like your constant file, all the helping file you can keep over here. So like constant file, all like app delegate, the main storyboard, and launch screen. I have just kept everything over here. So these are my resources, and then as I said, it's a MVVM. So we have view models which will be supporting our view controller. So in MVVM approach, just let me just talk brief about it. What we do in MVVM, we modularize our code a little bit more, so we don't overburden our view controllers. We will have shorter view controllers and bigger view models. So we'll be writing all our business logic in our view models, and we'll have a little bit less code. We'll have only view controller will only handle the UI. The purpose of view controller would be to show a UI, view model would be to handle our you know business logic, and our models, there's one more group model, will have our models like API response model, API request model. So over here I just needed an API response model, the gallery model. It is like, this is how I'm getting my response from the API, this is how my API response look like, right? So MVVM, we divide our code as much as possible. We try to keep UI related code in view controller, and no computation, no business logic should go in your view controller. Everything related to this view controller should go to this view gallery view model, which will take care of business logic and computation, right? And then we have so then we have our networking layer, which is like common layer for your complete application. So for this application, if you can see, we have a view controller, gallery view controller. So what it does, and I'll just give you a brief about it. We'll be talking in detail about the networking layer and the services, but UI, I can just give you a brief, like what we have done over here. So over here, what we have done, nothing, just we have called our gallery view model to get this data, and then in this view controller we have just created our collection view, right? With the collection view flow layout, right? We have initialized our connection view, and then over here we have created our data source and delegate for our collection view, right? So like all we are doing in our view controller is we are just calling get API data of our gallery view model, and then once we have all the data, once we have all these images from our API call, we'll just show it in our collection view. This is how we are showing in our collection view. So I'm pretty sure that all of you know how collection view works. So all this code would be available in my GitHub repository, so I'll be giving the link to that, so you can check out this code for sure. So this is my collection view, gallery view controller, and to support this, I have this collection gallery custom cell, which you're seeing over here. These are the custom cells, and then gallery view model would be the one which will be making the API call. So how this API call works is the main goal of this tutorial. So let's jump into the networking layer. So as I said, we have request, we have API call, and we have response. These are the three factors of any networking layer. You have to make sure that you have to create such a way that you can easily create your request, you can easily parse your response, and your API call can be done very easily. So we have created our API handler, which will take care of request handling, it will take care of response handling, and then we have API loader to make the API call, to make the final API call, right? So let's see. So this is my API handler. So ignore this code. You see, we have two protocols. One is request handler and one is response handler. So why this is why I said that we'll be using protocol oriented approach, because when you say protocol oriented approach, you mean it makes it more of MVVM type of pattern, because it makes your code more modularized, right? And over here basically what we are doing is we are creating a building block for our networking layer, right? So any services you'll be creating, you'll be extending these request handler and response handler. So what it does, request handler will make sure that we'll have one function which is called make request. So it will take care of making the request for our API call, and then response handler will have one function that is called parse response, that will take care of parsing the response once the API call is done, right? And both of these has associated type, so that the request type is generic. So associated type is a way to make your protocols generic, right? So when I say associated type, request type, any type of request, any type of parameter I can pass to this function to make my request, which will return me a URL request, right? So I can use this in my API loader when I'm making the final request call, right? And then in response handler also, I have associated type, so that the response is basically generic. Your response is generic. It can be of any type. So parse response will have two parameters: data. So after once the API call is done, we have data and we have response, which is HTTP URL response. It can give you a status code, message, if any error or anything you can get with this response. And obviously it can throw an error because we'll be dealing with the parsing different types of data, so it can obviously throw an error. That's why it is we have written throws. And I have given this a name, both of these type alias API handler. So with this type alias API handler, I can access both of these protocols, right? So so request handler doesn't just do request, it can have multiple other supporting functions, right? So we have request handler supporting functions. So in Swift, protocol can have extension functions. So it's a very good feature. Like for any protocol, you can write some common function in your extension, and then you can use those common function anywhere you're using this protocol, right? So in this request handler, I have created three helping method. One is set, to set the parameters. So basically what we are doing is we are just getting the parameters and we are assigning those parameter to this URL request. So that is why this URL request is an in-out type, so that it's not this function, this parameter is not a constant, it's a in-out type. So I can change the like I can modify it, right? So if param count is not null, then we will just get our JSON data from the parameters and then assign. So we have, for URL request, we have HTTP body, so we can assign this JSON data to our HTTP body. So it's a simple method which you use to set parameters. So instead of writing again and again, we will just write it in our request handler and use it whenever we are extending this request handler. And similarly, we have set query parameters. So for any URL, if you want to set parameters, you can just call this function. You can pass parameters and URL, and then this function will take care of setting those parameter to this URL, right? So this function will take care of setting the query parameters for your URL. And then last but not the least is the setting the default headers. So in my case, I am very sure that all my APIs content type would be of application slash JSON. So I have created a default header for all my API calls. You can like based on your requirement, you can write any other headers if you have, or if you don't have any default headers, you can just avoid this function. Or if you have any other function you feel you want to add, which you want to have for all your API calls, then you API request basically, then you can write it over here, right? So this is my request handler. And then response handler also have a extension function which is default parse response. So this is like default method to parse any response type. So this will be an generic function. So because response could be of any type, it could be like it could be a dictionary, it could be an array, it could be some kind of object which you have created, right? So that is why we have created it generic codable, because most of the response, like this is my response type and it conforms to codable, so that's why I have written codable. But if you don't want, you can have it like generic itself instead of codable, right? So and then we will be using Json Decoder. We will decode our response like this, as we do with Json Decoder, with our data type and then with our data response. This is the response. And then if response is 200, we'll return our parsed response. This is my parsed response, and it could be of any type, as we discussed. And then if there is any error, we can have a generic type of error as well. So I have created a service error struct which will have HTTP status and message. So all the error we can get status code from this response. And then if you know the error type, let's say if response dot status code is 401, then you can write specific message over here. And then in the catch block, you obviously have your error, then you can write the localized description over here, right? So this is how we handle our errors, right? And then if we do have a response, we can return that response using this function, right? So this is a generic function, that's why it can take care of any type of response which can which your which your API can return, right? So this is a generic function to parse a response from an API. Now, the main class, that is API loader, which will actually load your API. So we'll be using URL session, as you can see here. So API loader, if you see, it's a again a generic class, because we don't want our request and response type to be type specific. We want it to be any type. So I have created it API handler constant. So this type would be API handler constant. So it can have request data type and response data type, as we have created in our API handler. Request data type and response data type, right? So we can have so as you see over here, I have created an initializer for API request and URL session. Oh, okay. So this is created so that your testing, it is more testable. This is called dependency injection over here. So we are injecting request and URL session, so that if we want to test any API call, we can easily inject the request and we can mock a URL session, right? So we'll be talking about how we can do testing on this in our next tutorial. But making this injectable, making it dependency injected, we are making sure that this class can be tested very easily. And then we have a function load API request, which will accept request data of request data type, and then incompletion handler will have our response data, right? With it can return some error as well. So uh, it's a common URL session which we always do. So I can call my API request dot make request to get the URL request, and then with URL session, which we have initialized over here, I can call this data task and pass the URL session URL request, and then get my data response and error. And based on these, I can return my response, or I can throw some error, right? I can uh, return some error as well. So I think these are not required, because we are not returning, it's a completion handler. So this is not correct. Yeah. And then so this is our API handler. Oh, sorry. Okay, this is needed. This is needed over here, but not needed over here, because guard should have a return statement, but it's not needed over here. So yeah, so this is our API loader, which will load the API, and our API handler will take care of request and response, right? And then to support this API handler, we have multiple other enum and structs created. Like when you are creating a service, it can be of get type, post type. There are different type of HTTP methods, so I have created an enum for that. And then your API can be of multiple environments. So in all the companies, most of the companies will provide you development environment and staging environment, and then production environment, or different environment for services. So for development, you'll be using development services, right? So for that, it's better to have an enum named environment, and then you can have your base URL with subdomain and domain. So I have used unsplash.com. This is my API full URL. So for me, all the domain was same for development and staging and production. So this is same over here, but it will be different for you. It would be like .dev.com, or the main production you all will have .com only. And then you can have subdomain. For me, it's all same. And then you can have route. It's like /API/v1. So I have created this based on my API over here, right? I don't need route actually, but that's why there's no route you see in my base URL. So if you have route, I have just created this function. It's just a helping functions. If you need it, you can add it. If you don't need it, you can just remove it, right? So yeah, so this is how you can get URL based on your environment. If you are running in debug environment, in development URL environment, then you should use development environment URL, the base URL. The domain, basically the subdomain and domain will change. But if you are in production environment, you should use the production URL. So this is what it is. And then API parts. So for different APIs, so I have only one API in my application as of now. So I have only created one API. So I have struct path. So that this will have different parts. So let's say I have a login path. So it will look like this. Exactly the same thing, but in return I will have like um, so of course each of the URL have a base URL. So base URL will be based on your environment. So if you're in debug environment, the environment would be development. If you're not running your application in debug, then environment would be production for iOS application. And then based on your environment, you can call your base URL. So you have your base URL with domain and subdomain, and then you can add your path. So maybe my API call is like login API, right? Maybe it is called like this. So this is how you create. Now when you have to call it, you can just call this path dot gallery or path dot login. So we don't need this. It was just an example. So as many, no matter how many API calls you have, you should write all your URLs over here in this struct. That's all. So this is all your networking layer. You have API handler, you have in API handler, you have request handler and you have response handler. Then we have some extension function for request handler and response handler, which will take care of request and response. Request handler will take care of setting a parameter, setting query parameters, setting default headers, making our main URL request will be taken care of by our request handler. And then response handler will take care of parsing of our response. So any type of response we can parse it with this codable generic type of this parse function, right? So let's see. So our gallery service, this is my service block, and I have gallery API. So what I'm doing over here in my gallery API, I call this I just extend this API handler protocol, right? So any services I'm creating, so let's say login API I have to create. So I'll just create another file, login API, and it will look exactly like this. It will extend API handler, and I have to create these two methods. This is make request and parse response. These are the methods we had made in these API handler, right? API handler, request handler will have make request, and response handler will have parse response. So in make request, I will have some parameters, and it should return URL request. This was the contract of this is how this function looks like, right? So in this, the URL string I have to get. So I'll just call this path dot gallery, and I'll have my URL. So I have my URL, and now if from this URL request I'll get the URL, and then I'll just set my parameters. So this set query param is also a method of my API handler, the request handler extension method it was. So I just have to pass this param and then this complete URL, and it will set the query parameters. And then I have created my URL request with this URL, and then I can set the default handler. So I have called this set default handler with this URL request, right? And then I have, with this URL request, I have set HTTP method to get. So there it is, my URL request is complete. This is how all your APIs will look. Either it is login API, any other API will look like this. And then for parsing a function, parsing your response, all you have to do is just default parse response. If in case it is nothing different than this parsing, then it would be exactly like this. Maybe if it is some other type, if it is not codable or something else, I don't know, maybe you'll have to write some other functions in your response handler. But I think this will take care of any type of response you have. So this default parse response, we had written this function, so this will take care of parsing the response once we have made the API call. So this is our gallery API. And where do we use it? We use it in our gallery view model. So gallery view model will be the class which will actually be calling our API. So all I have to do is request gallery API. So I have the request now. Gallery API has taken care of making the request and everything for me. So yeah, and then I can just call API loader and pass this request, right? Request method which I have created, request which I have just created from gallery API. Now with this API loader, I can call this load API request, and it will give me my response. So response will be the model. So if it is an error, I'll just in completion block I'll just return the error, or otherwise I'll just return the model. So this is the whole thing, and this with this gallery view model, I'll be calling this gallery view model in my view controller, and then I can just, once I have this data, I can just show it in my table. So this is how our network layer looks like. I'm sure you might have like, if you have any thoughts that how we can make it more more modular, more reusable, more testable, then please do let me know in the comment section. But in the next video we'll be seeing how we can write how we can write unit testing on this class. Like how can we make our API request testable, and also we'll be seeing how do we do data binding between so in the next video we'll be seeing testing, like we'll cover the testing part, like how we can make our API loader testable. And next to that video we'll be seeing the data binding part. We'll see how we can bind our data in any other way than with this completion handler. Instead of completion handler, if we can use any other way to handle it, so that we'll make this gallery view model also testable. So right now this gallery view model is not very much testable because there's no injection, there's no dependency injection. It's just simply calling this get API data. So we'll make this class also testable, and we'll see how we can make data binding between gallery view model and view controller in different ways. There are multiple ways we can bind data between gallery view model between view model and controller. So we'll see that. So yeah, I think we are done for this video. If you like, then please do subscribe and like and comment, and let me know how you think about it. Thank you. Bye bye.